Hi, my name is Alessandro Gangelosi and that's a new tutorial for the lab tutorial library from Produce VFX School. Today I'd like to talk about clouds. Some days ago I released a video tutorial for the Redshift in production course, and in the lesson 10 I was talking about clouds made in 3ds Max and rendered with Redshift. So the idea is to try to replicate some stuff like that in Clarisse. Soon we'll have some updates in Clarisse about volumetric stuff. By the way, we are going to do some stuff with actual volume rendering shader we have. So I'm going to use some clouds done using the OpenVDB file format. You know that you have various ways to simulate stuff like that. So you can create VDB files in Maya, or you can create in VumeFX and Phoenix using 3ds Max, or you can use Udemy or whatever else. You can simulate with some software, or maybe buy some stuff, or maybe download some stuff, like in this case. For this tutorial I used the cloud set created by Walt Disney Animation Studio. It was released some months ago, and here you can see the link to download the OpenVDB file. In this archive you will find this cloud, and it is released in various resolutions. So you will find alpha resolution, full resolution, etc, etc. We are going to use the alpha resolution. It is not so big, but it is the quality is enough for our test. The rendering you can see there is done using a really complex rendering engine used by Walt Disney. If I remember well, it is called Hyperion, and it has some really advanced algorithm to simulate clouds and render clouds. So obviously in Clarisse and in other rendering engine, actually we have not so complex stuff to simulate clouds in this way. So the idea is just to understand how we can achieve a really nice looking clouds rendering done with Clarisse with actual feature in a simple way. Another thing we can do is, if you like, you can buy, for example, some pack with some clouds. This one is an example, and I'm going to use this one too, just to show how it works with VDB files coming from other software like Phoenix FD. This pack is done with 3ds Max and Phoenix, so we'll see some differences between the two different kind of volumetric files. So, inside the VDB file, the OpenVDB file is a standard. It's open source. It was developed at the beginning by DreamWorks, and then it was released as open source development kit. Actually, it is still going on with new releases and new feature. Inside a VDB file, we can find all information about a volume. So we have all information about the grid, and for every single point of the grid we have information about density, or for example temperature or speed, and etc, etc. If you know, for example, some simulator software, you know that we can save data inside the cache, and so you know that we can save different kind of data inside one file. So we have the possibility to pick some grids and some layers from the VDB file in Clarisse, and we are able to use it for shading purpose. So I'm going to create a really simple scene, and first of all let's go to create, maybe just going to have a better resolution there and better space. So inside the scene we get to save inside the context there for the viewport, so we see always the scene, and we are going to create a new context. So right mouse button, new context. This folder can be renamed, so F2, let's call VDB clouds. Okay, I'm going to import some clouds there. To import the clouds, we can go, for example, there, new, right mouse button, new, and then we can go inside the geometry and click over, geometry, and you have, obviously now it is not visible, but inside this menu you have volume, where you see box, file and surface. Obviously you go for file, and in this file let's try to have more space to play with our file, and let's go down and inside geometry, file name, and let's go inside the right folder, and lab December, look there, Clarisse BDB file. Okay, this one is the wool, isn't it? Yeah, you see that it is 400, around 500 gigabytes, so megabytes, sorry. So open, and it is opening the file. So actually the important thing is that there inside the density property we have to say which is the channel it needs to open. In this case the video file from Walt Disney Animation Studio has the density value inside. So inside the viewport, let's press A key, and you see that we see the clouds. So we have a representation like a geometry, so it is something like playing with a geometry at the moment. So you see that it's something like a shading. Actually it is not renderable with colors because we have no shaders. By the way, let's rename it, let's call it maybe Walt Disney Animation Studios Cloud. Okay. Let's go to save the scene in the right folder, so back there and inside the right folder. Okay, and there. Let's call it Clarisse Clouds B01. Okay, so let's start to playing with a lighting setup. So we can pick this one and we can remove it and the new folder, so right mouse button, new context, this one, F2, it will be lights. I like to have an HDR map, so we can maybe inside there pick one light, physical environment. Okay, F2, and this one will be the HDR light, or maybe we can call it dome. Okay, and then let's go to add also another light, and or maybe we can do it later. So let's start with this one, and here we can go to create a new texture map file, rename to HDR map. You can pick an HDR map you are using just to have something nice. I'm going to use an HDR map I bought some months ago, so inside, and this one comes from the City Skies website. So then back to the DOM, and we say to use in the color swatch as texture this one. Nice. So now we have the right illumination. Maybe we can just raise up the sampling quality to 2 key, and maybe we can start to have a nicer quality about the sampling. We don't go to something so complex. Maybe we can raise up later if needed. Let's go for 500. And later we'll see if this is enough, or maybe you can make some tests to have a faster rendering. I'm not going to do something complex about the lighting and not so much optimization, because I'm just going to play with the the actual render. So the next stuff I'd like to do is to have maybe later another light, but the first thing I like to do is to have a shader for this one. So there, new context, and this one will be F2 shaders. We go to have a new material and physical, and we have volume. Rename, and let's call it VDS shader. This one is for the Walt Disney Animation Studio. So let's copy and save. So let's make a camera using this point of view, and then inside the background layer we go to say to use this camera. Let's see if I just created a new camera there. So let's call first of all, let's rename it. So 01, and move it there, and then select the background, and we go to choose for camera 01. Nice. Let's go in the image, and actually it's going to obviously to do some lighting for the clouds. So let's go to add an environment, so context, and rename, and let's say utils. There we can go to create a sphere, and this one is the rename and sphere. The sphere can be really big in this case, so let's go outside there, and let's say maybe 5 kilometers. So obviously we see nothing now. Inside the shaders, a new shader, so new material, matte, drag and drop there, and the color will be the HDR map. Okay, nice. Let's pick the user mesh, this one, and this one will not cast the shadows, no receive shadows, and it is not an emitter. Okay, nice. So let's get to see the 3D view, and this one is just to be sure. I like to remove this camera, and let's create a camera from this point of view, back again, and there, let's say to use this camera. Okay, so we can just go near and move down, because I like to have a little different point of view. Okay, let's say with something like that for the moment. So save, and let's start playing with a material for this one. So you see we have not so much information there. We have just the scattering. The scattering is the color. Let's say the color is something like similar to the diffuse color for any mesh. So here you are going to say which is the color for our mesh, for our cloud in this case. And in this case we are saying that it is white, and there the absorption, it controls the light absorbed by the volume. So in this case it can be similar to the let's say the density, or maybe we can say it's similar to the transparency of the volume. So you see, if we go to something darker, it is starting to be more similar to a transparent medium, and we can go still lower, but obviously we have burning in the color, but you see it is still always more clear, more or less dense. On the other side, we have, for example, their density multiplier, and there we can decide how much density we are going to use. So if we say, for example, 500, it is more dense than before. If we go for 5%, you see that the medium is really poor dense, and it depends on the stuff you're trying to simulate. So let's imagine that inside the light we are going to add another light. In the HDR map we have the sun there. So if we go to use a new light, and in this case a physical, and we go for a distance, so we are simulating the sun, you see that the light is coming from the right side, and we can stay with the default sampling. Maybe we just use more sampling. And the first thing we are going to do, for example, is to pick the HDR map, and the dome, and see what happens if we have more lights coming from the environment. So maybe 2 for the main environment, so you see we have a better coloring about the environment. And then if you like, you can have just a little bit more light coming from the HDR map. Something I like to do is to play with the lighting. So I'd like to link light to the environment. So if we go to rotate something, we have something in real time done by the environment. So in this case, if we pick the distance and over the y-axis, we go to parent to the dome. Okay, in this case, if we pick the dome and we say rotate maybe -90, you see so you see that the light is coming from the back. An interesting thing is that we can link also the sphere. So let's go in the utils and sphere, and we go to parent this one too. So we say that it's parented to the dome. Nice. So now if we pick the dome and we go to rotate by 90 degrees, you see that we see the light moving in the right way. So now it is back the clouds, and on the other side we can see at -180. So you see how the cloud is changing its look. On the other side, you see that we can have also the light in front of the cloud. So that's nice. Let's get to -90. So we have the light in the back and save. We have one problem. The problem is that it seems that we have no scattering because we have really dark clouds, but on the other side the density is not so high. So just to be sure, let's go into save. Let's pick this shader, and we can have some optimization using the emission. On the other side we have also the possibility to say which is the direction of the scattering. Actually it is scattering on the backwards. If we say 100%, it is scattering 100% in our direction because it is forward scattering. So the light is on the back, and we have the camera there, so we have the all scattering coming from the back in front of us. So forward scattering is really useful when we are talking about stuff like some kind of volume based on water, and some kind of substance based on particles of water. By the way, on this test I think that 100 is too much, so I'm going to use 50%. So we have 50% forward scattering and 50% backward scattering. So we have the scattering moving in two ways. It is working better on the edges, and it is working really nicely. But the main issue is that we have still a really heavy shadows density there. So, well, the most interesting thing should be to work with multiple scattering inside the volume, but we have no way to have a multiple scattering feature there. So maybe we can play with the emission. The emission value is useful when you are talking about, for example, fire or explosion, because it is something like a self-illumination. So you see, if we go to rise up, you see that it's illuminating the clouds. If we go to use a lower value, or maybe you see also color, so we can play with this, and we can use it to achieve, let's go maybe to have less blue, and back to the brightness, maybe we can raise up a little bit this value. So you see, in this way we are going to have a lower density, so the cloud seems better because it is not so dark, and we have a nice looking scattering on the edges. So save again. So back using the light, if we go to change the rotation, maybe we can do something like that. So let's use 0 there, and let's see that we have a keyframe there, and let's say that we have 200 frames, and at the end we have minus 360, and we have another key. So you see that we have the light moving around, and this way we can simulate how much light is moving. Let's say it is not bad. I mean, it is nice, and you know, actually it is not so much dense. And if we move forward, you see that it's playing nicely with the lights. Maybe we have just a little bit bright area there, but we can play with the scattering color and maybe rise down a little bit the color. By the way, the look is not bad. And maybe it's not bad to have this too much white on the border, and you see that there, then we have a new lighting there. By the way, if we like, we can, for example, go there, and we can see two things. One is rising up the density. So let's see what happens if we go back to 100%. You see that we have a lot of details coming from the clouds, and maybe now it is too bright, so we should have something darker there. On the other side, maybe with something lower, like 25, we are going to have something nicer. So it is not so much dense, but it is nice playing in this way. By the way, again, it seems a little bit too bright, the actual emission. So we can go to play a little bit with this value to control in a different way what we are trying to achieve. Okay, on the other side, about the scattering, we can have an higher scattering, so we'll have more white colors. So maybe in this special case we are finding a better compromise, but you see that there we have not so much white, so maybe we have to go a little bit lower. On the other side, if we go back with the light, the cloud is really dense, and it should be not so bad because, you know, it is working, but maybe we can have to do something more complex, and you know that we can play with the density, or maybe we can play with the emission color to have something different. By the way, let's go to clone this one, so maybe save, back in the 3D view. Let's make a copy. Let's create a new 3D view, and let's move it with the V key. So this one maybe, sorry, we say copy and then paste. So the second clouds can stay there. We see, okay, maybe something like that. So you see we have a cloud also on this side. So save back in the image view, and that's our cloud. Maybe we can pick the first one and move it a little bit down. Okay, back to the light, the dome, and let's go to 180. So you see that's the result we are actually achieving. That's not bad. Maybe it is a little bit too puffy, but it is not bad. So playing with the playing with the scattering, the absorption, and the emission is giving us the possibility to control in a better way how it looks. Let's see what happens when we have 100%. You see that in this case, obviously, it is not so nice. So it depends. That's why I'm going to use 50%. So we have backward scattering and forward scattering both on the same simulation. Let's see. So this is the basic approach to have something. Maybe we can play with an actual simulation to have something more complex. So the idea is to have something more, something stranger. This based on some tests I done, and I was trying to use different texture and nodes inside Clarisse to find a different look for our shadows. So I will change this this shader to be more similar to the one I tested days ago, and then we'll see how to use the same approach, maybe in a little bit different way on a different kind of VDB cloud. And then if we have time, we can try to use another shader I'm working on. It is a prototype, so it is not complete, and maybe it doesn't work all the time and in all lighting condition, but it is another idea I'm working on. Okay, so first thing, let's see what happens if we have, for example, 0.5, 0.5, and 0.5. You see that we have a really high emission. So let's go back to something low. Oh, sorry. Obviously, you can use some kind of color there without problem. So let's go to play with the scattering. So we are going to try to use a different kind of solution. So let's go for 100%, and maybe we can select this area. Okay. So shaders, VD, and let's go in the material editor. Okay. Maybe it's better to work there. So let's add the material editor there. Okay, and let's use more space. So that's our shader, and we are going to use, for example, let's say a Fresnel. So let's go to copy Fresnel there, and we go to control the scattering based on a Fresnel. You see that it's changing the way it works, and the Fresnel is based on the on its parameter, and in this case it is set to 1.5. We can go for something similar to water. Obviously it will be a little bit different, and this is to trying to evaluate in a different way the colors over the cloud, and it is not so so simple to control what I'm trying to do. By the way, let's try to change the color. So let's go to something bluish. Okay, you see that in this way the cloud is going to bluish because it is completely blue. By the way, if we go to have, for example, one there, we are going to another color. So it depends on what we are trying to do. So maybe before using this one as a single color, we can maybe decide to control the Fresnel maybe with a gradient, or maybe use another kind of stuff. So maybe we can use the extract property and connect the extract property to the color. So the extract property will extract the density. So we have again, the color is based on the density actually, and then we can try to use a gradient there. So let's try to go for a gradient. The input, so the driver for the gradient is the density, and then we connect this one there. So just for a moment we can try to not use this one. So inside the gradient we can try to make some differences to see how the gradient will look. So let's go inside the gradient and let's see what happens. For example, if we add a point there and we pick the red, you see that the clouds are changing the color, and the density is based on, so you see that there we have less density, there we have more density. So it depends also on the file, so it is not so simple to drive in the right way a cache that is done by someone else. So let's try to make something simple. So maybe we can go for white there, and then we go for white again. White, and then we go for maybe there we can have a black, and then let's go for a white color again, just to modulate a little bit the colors and to have some variation in the cloud. And then back maybe the black, and then maybe back white, and then maybe back black, and then obviously the last one will be white. So we have some kind of variation. Okay, so you see that it's not perfectly white. We have some kind of variation over the volume. In the material, the idea can be that, for example, then the Fresnel can control the input there, but we are going to partially remove the effects we had before. So it needs to be decided. Maybe we can use it, maybe we cannot use it. So let's see if we have the pass-through. Okay, so it is not playing enough with the stuff I'm doing. So in this way, if we go directly with this one, we have this. If we go with this one, we have this. And if we go with this one, that's the result. Let's see whether including this one. Maybe that's the best compromise. It is a strange thing, this one, but it is working nicely, so I like to have it. So then we have to use something about the emission too. So the idea is to use something similar. So we go to use this Fresnel 2, and then maybe we go for a different gradient. So let's use this one in the emission, and maybe let's go to control with the parameter we have inside the density, and the idea is to have something bluish. So maybe we can go for, let's say, black there. So we have no emission in this way. Let's see. There we go for something bluish. Maybe less saturation. Okay, and we pick another point with black, and we move it. And this way, maybe it is better to move on the other side. So maybe let's see if we have white there. Let's remove this one, and this one will be dark bluish. Maybe you can tweak it a little bit. Let's try something different. So let's go for black at the beginning. So actually we have, until there we have no self-illumination. Let's say simulated scattering inside the volume. And then maybe we try to go for black also there, and black there, and let's try to have something around the color we'd like to have. So you see that where we have less density, we have this coloring. So maybe we can go for something clear. And about the saturation, let's go for something like that. And let's just tweak a little bit, and this one maybe can go lower, and this one can stay around this value. So you see, depending obviously on the color we have some kind of different lighting. So for the moment, let's say maybe just a little bit more bluish. Okay, and then we'll work more on it to understand how it looks. So let's see also the other one. And talking about density, just to remember, we have 20%, and that's at the first frame. Let's see when the light is on the other side. So that's when we have the lights in front of us. Okay, obviously the density is a little bit strange because we have less density on this area and more density there, but we have not so much control over this kind of effects because the file is not done by us. Let's see what happens if we have, obviously with higher density we have really dark clouds, but just to be sure I'd like to to see a piece of the cloud, just a little piece, to see how it is looking, to see how much lighting and scattering we have inside the volume. It seems not bad. Maybe it is a little bit dark, so let's see when we have a lower density, like 10. It is working better, obviously, but the cloud is not so much dense. Let's go back to 20, and let's see, playing with a forward scattering, maybe less. Okay. So in this way we should have control over the scattering, playing with these values. So you see that in this way we got to peak a little bit more this area, so we can have a more brilliant scattering simulation, and you will see more and more of this stuff. So in this case, maybe this area is not so nice, so it means that maybe we can move this one. You know, this area is really clear, because there we have a really strange different. So let's go for brightness. Obviously it is not simple, because the cloud is done to work in any way we are not using, so you know, it is a special case, this one. And back to backlighting, just to see how it looks. This is light coming on from the other side, and this is backlight. I think we can play a little bit more with the lighting. So actually we have the distance light is with the default exposure. Let's see what happens if we go a little bit higher. We start to have more white area on the side. And when we have the cloud on this area, it works in the same way. Let's go just a moment there on the cloud, and we go to move a little bit down this one, because I don't like to see this piece, the lower area. Okay, so it is less visible. So you see, that's when we have the sun lighting the cloud and we have less shadows. It seems not bad. Maybe in this case, you know, you have always the control about the shader, so you can work on this part of the scattering. I mean this one, and let's say it before. And you can do something. So for example, in this case we can change a little bit this one, and let's see what happens if we go. Maybe it is not playing so much, this one, so maybe we can decide to remove it. So maybe it can help, and in any case maybe it is helping less, so you can decide if it is useful or not, but in some case it works. On the other side we have the gradient, and maybe we can play a little bit with the gradient too. So just to play this one, you know, this is a dark area, and on the other side maybe we can try to pick also this white color there and move to have more white. Okay, back there, and let's go again in the attribute, let's see if we have a little bit more scattering. It seems not bad. I mean, then back to the light. In this case, maybe if we have still higher intensity for the exposure, you see the cloud is starting to be more white, and depending on the stuff you are doing, you can have less density over the shadows, or maybe more. It depends on the density of the cloud. So, you know, in this case, if we go there, let's try to have a bigger area so we see also the other shadows, because, you know, it takes a little bit to show the real quality of the rendering. So you know, depending on how you are playing with the density and the other stuff, we are going to achieve a different result. So you know, back there in the density, if we play with a low density clouds, obviously it will be more white with less shadows, and maybe it will be a nice looking stuff, but again, it depends on the stuff you are trying to achieve. So it is a different kind of cloud and a different kind of quality and look. So, you know, you can achieve whatever you like. It is not so complete, and you know, you have not a really amazing control, but you can simulate some kind of strange look in this way. Okay, let's see what happens when we have the full density cloud. Obviously, if you have the full density cloud, it will be really dense with a lot of details, and in this case, maybe you have to tweak more the simulation for the illumination, you know, about the shadows, because you see we have really dense clouds, and it seems that we have really dense shadows, but you know, it depends. It seems not bad, so maybe playing a little bit with illumination can work. So back to 25%, and let's see another case. And in this case, I'd like to talk about a different kind of cloud. So in the VDB cloud, I go to merge another cloud. So new and geometry, and we go for file in the volume. This one can be renamed as, let's say, Phoenix FT, just to know that this one is done using Phoenix. And we go to load file, so file name VDB, and we go for this one, the 3D view. Okay, it is there. And we have to use another channel because it is using the density, but inside the Phoenix we have the smoke. Okay, so you see now we have our cloud, and let's go to scale this one because, you know, it is little, so let's try with 5. Maybe this one is not so nice. Oh, sorry. I don't like it so much, so maybe we can try to load the other file. So let's go for the C. This one is a little bit nicer. Yeah, it is nicer. So with the V key, I go to move it. I'm not going to fix the you know, the pivot. It is not my main problem. So let's go in this area, and we can move it up So inside the 3D view, or maybe directly there, we can raise up its position, and in the 3D view you see it is up. Okay, let's go in the shader, and actually we go to assign this one, and obviously you see it is a little bit different, so we need to do something else. So let's save PDB 1 and 2 and right mouse button, and you can click on disable, or you can use Ctrl D. So that's the cloud, and we can, I'm sorry, okay, it seems not bad, because maybe you can create something like that, but the shader is wrong, so we have to do something else. And in this case, if we go to play with this material with a shader, let's see what happens if we go to use another volume. Okay, and or maybe we can just copy this one, or maybe we can redo from 0, because it is better to start with a new one. So material, physical, and volume, F2, and this one will be Phoenix shader, and copy. Okay, it is set to 100%. Let's go to 50 about the scattering, so it is half in front and half on the back. You see that this one is not bad with a standard value. By the way, we can obviously play a little bit with the emission. So you see, in some cases you have to do not so much stuff. So in this case, maybe we can just go there, and let's use again the extract property we used before, and we go to control the gradient again. So input is this one, and we go to control the scattering with this one. By the way, this time we have the smoke. Okay, and the scattering, let's go for a bright color, so we see the difference. So you see there the density is more clear, so it is more simple to do something like that. So let's go for, let's imagine for example that we have a dark color for the outside to have some kind of more dense edges. Let's see if we go for black also there. I like to see how much we can use this black. In this way it's really too much, so maybe just an area like this one. And then there we go for maybe a grayish color, and there it will be fast the passage from black to white. So you see we have really high quality edges over this cloud, and then it is moving really fast to have a different look. And if you like, obviously you can have sometimes some more darker area. By the way, obviously we try to have again white color there to create just some details over the surface. So again with a black, and then again with a white. So in this way we are just going to create some details over the surface. So you see that we see some curves over it. Maybe black is too much, so we can go for a gray color. Okay, it is really high visible, so this is the frame 150. Let's see when we have the light on the other side. And let's see when the light is on the back. Let's see there if we need to have higher density. And again back to a lighting coming from the side. You see the nice detailing we are achieving there. It is a different approach than the previous one, but it works. And maybe we can go, or maybe this one can be removed and we go just to have a little bit of grayish over the cloud body. Just a little bit. And maybe on this one we cannot tweak the emission, but on the other side we can play a little bit with the color because it is going to be really bright, and you know we have a lot of burning, so maybe it is better to go a little bit lower with a white area. So you see we have a little bit less white on this side. Let's see what happens when we light it moving back. You see that it's starting to play nicely because we have a really high white area around there, and then we have the dark inside. Same here. You see we have the sun back the cloud, so it is a really realistic situation. And let's go to move the cloud, the sun. So you see how this is changing step by step, and it is working really nicely. It is nice that we are using this way to create a lot of details on the cloud. Let's see when we have, so this one, and then the light is coming in the front, and it is still working nicely. Okay. And back again to the previous look. So just to see how it is working, let's go in the path tracer. You see we are going to use maybe the Blackman Harris, and then about the anti-alias, let's go for something either. Maybe nothing so special, but just be something to have a nice looking quality render. Okay, you see that it is really nice. Obviously we have still some noises, but it is due to the low sampling we are using. We are not playing so much with the sampling. We can go to the 3D view, maybe the first one. Select this one and make a copy and then a paste. I get to move it. Let's move it there and maybe there, and we go to use another file. This is the J file. It is another file as you see, and maybe we can rise up the scaling. Obviously the scaling can be not uniform, so Let's see, you see, we can go for something strange if we like. By the way, I'm going to do something like that, and then let's go back in the view, and maybe this cloud is back. 3D view, let it be there, and we rise up this one. So see, we are using the same shaders because we have the same settings as the other one, so we can use it without problems, and it is working nicely with this cloud too. So you know, it is a nice approach. It is maybe not the best physically accurate solution, but it works nicely, and you have a nice control over colors and all the other stuff like the density and etc, etc. So it seems nice, I mean. So you see, that's the actual setup, and it works nicely with this cloud too. So maybe just to go in this view, let's pick off, and then you can enable with the Shift-D key. So we can just back, select this one on the back, and maybe this one can be moved down. Let's say that we can do it there. So we go for something else like this one, and maybe this one a little bit there. So it is on the back. You see, we have some different kind of clouds inside the scene. So we are simulating different kind of look, and let's wait to see how it looks actually, and then maybe we play a little bit more with the emission for the big one, I mean the center cloud there, and then we stay with the final result to see how it looks. So save, and let's see the final look. Okay, so you see, maybe let's go for a lower resolution. This one is really more dense. Let's select both. It's better to work on this one. So maybe we can go a little bit lower with the resolution there, the density, and then we can play a little bit more with the shaders. So in the material editor, let's go in this one, and let's see what happens. For example, if we go to raise up this color, and maybe we can do something interesting to have a color similar to this one. So let's pick there, and we have this color, so let's store there, and back in the material we have the gradient one, so let's use this one. Okay, sorry, use, okay, and then use, okay. So obviously the density is higher, so we have to go maybe brighter, and let's try to go brighter to something like that, and we do the same with this one. By the way, you know that this cloud is has a higher density than this one. It is real that there we have a higher density value, but you know, this cloud has a different value of density from the file, the simulation, you know, so that's why we can have a higher density on this one. Let's see. Okay. So you see two different approach to the problem with different cloud look, different density and different file. By the way, you have different ways to control how it looks in a really nice way. So again, let's go for something not so much dark with a lower density, just to see how it looks. So you know, obviously we have a lot of white there, a white burning, but you know, this one can be a little bit less if you work on the color of the cloud and if you work on the also on the lighting. So it depends on the stuff you are trying to achieve. So it is a really nice working setup. And again, if you choose to go for higher density multiplier for this cloud, then you can go to rise up the emission. I mean, if you have there, for example, let's say 25 that we are using, you know that this one is really dark in the clouds. It is not so much dark, but you know, it is darker than the other cloud we have on the back. So in this case, if we go in the material for the cloud, sorry, there, this one, you know that we can control how it is playing. And you know, if we go to disconnect this one for a moment, you see that we have a really high brightness. Let's go to control again, something like that. You know that we can always go to play with this control. So we can, for example, rise up this one and the cloud will be more clear, and the you know, the shadows will be less dense. And again, maybe we can find this black to understand if it is, for example, this one. So we are going just to play, it's not this one. Let's go if it is this one, and in part is like this one. So we can, for example, remove this part, and then let's see, we can go lower and lower with this. So we'll have just a little bit of no self-illumination there, maybe just a little bit clear, and this one can be removed. We can go just a little bit darker maybe. So you know, you can change the look as you prefer, using the gradient and the approach we are using at the moment. Obviously, in this case, maybe this cloud is reacting in a bad way to the sun, so maybe we can go down with this one a little bit, and on the other side, maybe it will be better to have back a light with less energy, you know. So in this case, we'll have less white, and the cloud will works in a better way. So it is really simple to use it. You can control the stuff as you prefer. And in this case, obviously, the cloud on the back are darker than the cloud on the front. And obviously, this kind of clouds will react in a different way to the sun from behind. But you see, it is playing nicely on the side there. So you can play with it freely and you can find your best solution. Another interesting thing I like to show you is that the possibility to control the density multiplier with a map, because inside the shader, let's go in the first one there, we have also the density multiplier property. So if we go to pick, for example, a procedure, let's say a Perlin, and we go to, let's close for the moment, and we go to connect to the density multiplier, and let's go in the property, right mouse button, open with texture view, so we see how it is playing. Let's say that first of all, let's go for a little bit more high, and let's go for a turbulent one, so we have this kind of stuff. And let's go for something like that. You see that we are controlling the shape there, so and it's nice because you see we are changing the shape of the cloud just playing with the shadow map. So we are not using just the density we had before, but the way we are playing with the density we had before in the grid, and we are changing the shape just playing with this noise. So if we can obviously play with all control we have there. So for example, you see I can change the linearity, and if we go to have an octaves, obviously we are adding details, and let's say to rise up really complex stuff, and then we go for maybe have adjust some area like this one. You see that the cloud is changing completely, and back you see that we can have also animation, and that's nice. And back maybe in gradient, let's remove this one, and this one is there, and this one will be a little bit darker, and this one will be darker too. So we'll have something else. The shape is completely different than the previous one. So you see, we changed the cloud just playing with the noise, and that is really nice. So you can let's say remodel the cloud just using the noise and or the texture you like. Obviously now you have no more control over the density there, but you have to use the texture. So if you use the pattern, it means that, for example, there you can have no completely white. Maybe we can go a little bit lower to have less burning in this area. Let's wait just some frames to see how it is looking. Or maybe we can do something like that, have the maximum density there, and instead having 0 there, we can have the cloud. So you see we have maybe less density, it is starting to disappear, the cloud in this area, when the noise has the black color, and then maybe we can just play with the color there. Or maybe we can do something more simple. So you have always the possibility to control the color there. So let's say that we have maybe the contrast. Right mouse button and open with texture editor. Obviously that's not right, so let's go to connect to the scattering, and we can go lower to have a little bit less contrast between the color, and everything will be a little bit less white. There's a way. Obviously we have a little bit less difference, so maybe we can try to do something else. This is a way. You see that it is working nicely. So let's wait to have the final look, maybe with let's say 50% quality. So you see that's the actual result. Obviously we can tweak more some stuff, but it is nice to know that using the density multiplier with a procedural map, we are going to create custom clouds shape just playing with VDB files we loaded before. So I think that's all for the moment. That's the first kind of approach we can have inside Clarisse to have some believable clouds. We'll be back on stuff like that to talk about smoke and fire and explosion. So we'll work more on volumetric rendering really soon. So thanks for watching, and I hope to see you back on our TheLab tutorial library from Proteus VFX School. Bye.